lie below the plane. So the meaning of that one. Now here what happen if I place a satellite, mass of satellite bm, mass of the earth e, and radius of the earth, let it be r. So what is this height? This height will become now h. This is called like a altitude. What is h? It's called as altitude. I'll measure from the surface of the earth. Now here the satellite will be having a speed. So who will provide required centripetal force? I think I'll put dotted line. The gravitational attractive force will provide required centripetal force, and this particular satellite, it will have a tangential speed. Okay, that we'll calculate later on. Then how the satellite, there's an equatorial plane. So where the satellite, it should lie in the equatorial plane. Then what happens? With respect to some point on Earth, it will appear stationary. So let there be a person is here. I'm making this person. This person is standing. With respect to what happens, the satellite will appear stationary. So what should be that height? For that, what should be the time period of the satellite? By the time the Earth completes, so there's a reference point. Now the person is standing here. By the time this point on the Earth goes round, and it takes 24 hours, no? In that, what happens? The satellite also happens should take same time to go around the Earth. So if that happens, what happens? Then you can say that it will become geostationary. I think word, okay, stationary. So what this person says, I'm seeing the satellite. You will not see to make you understand telling at a height of 36,000 kilometers. How do we can see? Not possible. To make you understand, I'm seeing this satellite at rest. You will comment like this. For me, the satellite is at rest. All the time the satellite will appear. Then I can go for communication. With the help of 3 satellites, almost we can cover the most of the part of the earth. Suppose say with the satellites here, no? So living this region. So this all of this living the polar regions open with the help of geostationary, we can cover with the help of 3 satellites. So these are not accessible. These are not accessible if satellite is here, no, because the signal sent by it will come only in this range. It cannot go beyond that one. So these polar regions are not accessible. I think there's just only some small basic idea. So 3 satellites which are separated by an angular separation of 120 degrees is sufficient for the global communication. What to do for polar regions? I'll go for other polar orbits. With the help of polar orbits open, I'll cover the communication for the polar regions. Let's not go for communication part all. So let me combine. So what is that H? How to find out? So we'll provide required center of the gravitational attractive force. So F is equal to GMEMS H plus R whole square. And what is this force? Mass of satellite omega square of satellite R is equal to GME ms by H plus R whole square. Now what is omega s? Omega s should be equal to 2 times of time period. So what is the time period? Substitute that 24 hours. T is what? 24 hours. Solve it. Solve it. MS get cancelled. G, ME, all the values you substitute, no? So we'll end up expression for this is 35,786 kilometers. This will call as altitude. Altitude, all of you will measure from the surface of the earth. From the center of the earth, it will be H plus R. If a satellite is located at this much of height, at a height 35,786 kilometers from the surface of the earth, then it will remain geostationary.
Sir,
With what speed it will be moving? It will be moving with a speed of 3 kilometers per second.
sir, for calculation of centripetal force, we have to take R plus H, no?
Okay, so wait, some omega square R plus H. Oh, fine. H I am measuring from surface. No. Okay. Okay. Thank you. Yeah. Okay. This it's a simple calculation. There nothing big. So it will appear stationary, that one. Only at this side. Sir, what happens if it is at height of 20,000 kilometer? You definitely go for this one. As you increase H or this one, get expression for time period in terms of H and UC. It will not remain geostationary. We are bothered about geostationary. So what is the basic condition? The satellite should lie in equatorial plane. And if it is at a height, at specific height, then it will appear geostationary. If the height of satellite is less than 35,000 or more than 35,000, or this particular value of 35,786 kilometers, it will not appear geostationary. What do you mean geostationary? It will appear at rest. Means now few things like sir, same thing like if there's a satellite, there's a Earth, and there's a equatorial plane. Let me launch satellite here. Can it be? What is the axis? This axis. Huh? The Earth is revolving about this axis. Now look at the orbit. How the orbit is. Red color. I'll put orbit. Can it be geostationary? I'll give better diagram. There's a Earth. There's the axis about which the Earth rotating. Now, a student says that, sir, why can't this be geostationary like this? Satellite is going to be here. Can it be geostationary? Not possible, no. I think you know enough of circular motion. You know enough of circular motion. Not possible because there's a equator. Huh? There's a equator. There's a north pole, south, west, east. It is not equatorial plane. Am I right? So definitely, open the orbit must lie orbit of satellite. Sir, here also I took height. It cannot be geostationary. Say this person, the person is here. After some time, he'll be here. What about this satellite? It will be, there'll be relative motion. No? So shall I put in simplest way? Between the person and satellite, there won't be relative motion. Here, open, you take any person. Let me put that person here. I myself standing here. Will there be relative motion between the person and satellite? Yes, there will be a relative motion between satellite and person. Is it agree now? So no question of geostation. When geostation will be there, when there's no relative motion between a point on a surface and the satellite, then it will be geostation. Not possible. So strictly, what should be the orbit? Orbit should lie in equatorial plane. These are small things they can ask you. You have to be careful. I'm seeing the satellite at rest or no relative